Today I'm going to talk about the LeetCode problem 274 H index. This problem is rated as medium, but I believe like many people when they first look at the problem, it's not very straightforward to understand. Let us reading the description. It says a scientist has index H if H of his or her N papers have at least H citation each, and the other N minus H papers have no more than H citation each. So here the H appears many times, so it's not very easy to understand. So I transfer this description to a way maybe sounds more familiar to engineers. So this is the new description. Given a long negative integer array, let us try to find a largest k. So we have like a k elements lot smaller than k. So here, let's check example. So we have this array 1, 6, 1, 5, 6. So the final answer is like 6, 5, 6. Because we have like the k is equal to 3. Let's check why the k is 3. So um, how about we choose like 2? You can see here if we choose 2, we will have like 3 elements larger than 2. So because we want to find the largest k, so 2 is not the final answer. How about we choose 4? You can see we don't have like a enough number, like 4 number larger than 4. We only have like 3 numbers larger than 4. So 4 couldn't be the answer. Um, I think if the array is not sorted, it's not easy to find the what is the target k. Uh, so so here I think to resolve this problem, we need to like first sort the array by its values. Um, so here you can see if I sort the array to be 1, 1, 5, 6, 6. So I think now maybe it's easier to resolve this problem. We can just go over from the right side to left. So and check one by one. So here I go to 6, and now I have one number. It's itself 6 itself. So like 6 is larger than 1. So but we are trying to find the largest k. So 1 is not the maybe not the largest one. So we will trying to find, and here k is equal to 2, and 6 is still larger than 2. So 2 may be a candidate, and we go to the next part. So we now increment the k to be 3. 5 is still larger than 3, so 3 is still a valid candidate. But after we move to this one, now k is increment to 4. So 1 is not equal or larger than 4. So 4 cannot be a candidate. So we find the final answer, which k is equal to 3. So here, I think the first solution is just trying to use a program to simulate the process. So here you can see I have this code already written down. We have input as a array. First, we sort this array in increasing order. This complexity is like n log n, and we define one k and one result. As I said before, we just go over the array from the right side to the left side, and we have a k to count like how many numbers we already processed. So uh, for example, if we process this 6, k is increment to 1. And we evaluate uh, if its value is like larger or equal to k. Because we want to find the largest k, so we in every round, if we find the valid case, we just compare if it's still the largest one, and finally we return this result. So the algorithm is like fairly simple if we understand what is the problem is looking for. Okay, we already solved the problem with a time complexity, uh, which is like n log n. So I think one follow-up question we might get from the interviewer is like, can we do better than n log n? So here, as we know, the bottleneck of this problem is like the sorting at the beginning. So here we are going to trying to improve on the sorting part. So I think the second solution, which is the follow-up solution, maybe need some like a background knowledge. First, you have to know like a count sort and our bucket sort before. Otherwise, it's not very easy for you to come up with follow-up solutions. So as I understand, counting sort is like a more strict variation of bucket sort. Uh, for example, what is bucket sort is like you can go over this list, and you can put the elements which share the same attribute to one bucket. So in this way, you don't need to do swap for all those elements. So I think the time complexity is just O of n. Go over this example to see how exactly this new solution works. So first we have the same like array, which is like 1 6 1 5 6. So we need to define a new array to record the counts of each value. So we define the new element, new array as the size as the previous size plus 1. And we go over the original array and increment the new array accordingly. So first we go with this 1. So we increment the index 1 by 1. And we check this 6. So there's one extra thing we need to take care of. It's like because the number the in the original array could be extremely large. For example, this is here the number is 6, but it could still be like a 100 or 10k or something like that. So here one tricky thing is like we don't want our new array to be extremely large. So we need to do something is like if the original number, the value is larger than the size of our new array, we just increment the number for the last index. So here we saw 6, so we just increment the value for index 5, and we process 1, we increment the index 1, we process 5, we increment the index 5, and 6 increment the index 5. So the final the counting for each value is like this. So the second step is like we need to trying to find the target key. So to find the target key, we are same we go over from the right side to left side. So and here we need to record a sum. So this sum value um, will be the total number we have processed, which is like larger or equal to current index or value. So here is like we process this 3 and the sum is 3. So it means like we have like three numbers uh, larger or equal to 5. But to the criteria of k, we need to find like maybe at least 5 number larger or equal to 5. But we only have 3, um, so now there's no candidate, and we move to the left side. That means like now the sum is 3. It means like we have like 3 numbers, which is its value is larger or equal to 4, but it still cannot meet the criteria. So we move to left. Now the sum is still 3, but we have like 3 elements larger or equal to 3. So this is already meet our criteria. So we find the final number, which is like 3. So here you can see I read down the code. Um, so we just simply go over this code and see how it works. So first, as I said, I create a new array to store the count for each value. The size is like the original size plus 1. And we go over the original array, and we need to check if this number is larger or equal to the length of our new array. We just increment the last index. So here I can change this to a larger format. Maybe it's easier for you to understand. So here, if it's if it's larger than larger or equal to length, we just increment the uh, index of last one. Else we just increment the count for the value. So and we have defined another like a sum. This means like until now how many elements we processed in total. So here we just go over the new array from right side to the left side, um, and we sum up the sum value, and we check if the sum is like larger or equal to I. If it's like meet the criteria, we just return the I, which is the final answer. So here I think it's now the problem, two solutions.